And welcome students to our next section for Programming 3. We're going to segue away from talking about data structures, even though we could keep diving more into like binary trees, we could dive more into recursion, etc. Instead, like I said, we're going to look at some different programming languages because when you go into programming as a career, you're not necessarily going to be locked into one language. Like you might get a background in Java, but the job you apply for might be for C++, for example. So you need to have a little bit of background knowledge of how to interact with different languages. And sometimes when you're working on a project, sometimes one portion of the project may be primarily built, let's say, off of Java, but its web interface might be using some Python extensions. So it's good for you to get kind of a little bit well-rounded and also see how you can translate your skills from one programming language to another. So to get started with that, if you haven't already, we're starting with Python. Python is a great programming language. It's pretty easy to pick up. Part of the reason for that is that it does not use our standard end line markers like semicolon, curly brackets, stuff like that we're used to with Java. Instead, it uses more what's called dynamic white spacing. So it uses like a new line or indentation to help indicate where the code all belongs. So to get Python, you just simply go to python.org/downloads. And you can download it. You can see right here, this is version 3.81 as of this recording on this website. Sure, by the time maybe you get to doing it, it might be something different, but that's okay. So you just completely download that and install it. Now, you can use an existing IDE such as Eclipse. There are plugins and stuff that you can use to integrate it in. But the nice thing is Python actually comes with its own integrated development environment. It's this one right here. It's idle. And when you launch it, you'll see I'm using version 3.7.4, so it's a little older than the version on the website, but that's perfectly fine. It works exactly okay for what we need it for the purposes of our exercise. So once you launch it, you download it, install, launch it. What do you do? Well, this is our command line inside of Python. So if we were thinking about Eclipse, it's like the little console window that we have at the bottom screen. So this is where our output's going to be generated. So I'm just going to go ahead and slide that note over here for now. And I'm going to go ahead and click on File, New File. And that's how I can make a new file in Python. Then, of course, I can start typing like usual. Now, you notice that there's no pre-made structures that I can use. Like Java, for example, like public static void main string args. There's no public static void main string args here to worry about because, well, Java is a object-oriented language. It's based primarily off of C++, which was based off, of course, originally off C, which we will look at eventually. Python is more of a general use language. That's why it's not necessarily locked into kind of one field set or another. So when we get into working with Python, you're going to see there's a couple quirks about how certain things are used in comparison to what we're expecting to do in Java. But it doesn't take much to catch on. So if I want to then, of course, save a file, so if I go to File, Save, one of the things you'll see that its extension is .py, and we can just save that to our desktop for now. I see I have some existing files out here. So if I want to open an existing file for any reason, I can just go to File, Open. Let's go to Desktop. Let's see if I open up Demo. You can see here's some example code right here. If I open up that test file that's on the desktop, you can see here is another example of one. All right. And of course, you can see this one has some loops and stuff like that. But for our purposes, let's go ahead and create a new file here, which I've already done, and save that. And I'm going to stick it on the desktop again, and I'm going to call this Programming 3 Demo. Just so I can differentiate it from the other ones. All right, so now that's saved. What's next? Well, let's start off with our good old friend, Hello World. Because after all, that's a pretty standard way to start off a programming language, is saying, how can I do Hello World? Well, in Java, we had to do public static void main string args, system.out.println, and then Hello World. Python, it's super, super easy to make a Hello World program. Literally, just do print Hello World. That's it. That's your Hello World program. And I can prove it by running it, and of course, I can go up here to Run and Run Module, F5. So I could just press F5. It's going to ask me to save. I click OK. Boom. Hello World. That's it. And if I press F5 again over here, and you can see Hello World is there again. So it's super easy to make a Hello World program. Now, there is a few fine things that we're going to do because I don't want to simply just dump a bunch of code in here. Like we can start immediately just start jumping into, okay, let's make variables, let's make strings, let's start printing them out, let's get user input. I wanted to get us into the habit of making a little bit of structure in our programs. So we're going to take this out here. Remember, this is all being done live. I'm not pre-scripted on this. So there's no like master slide over here of things telling me what I need to say. So let's hopefully I don't mess anything up. So the first thing to understand is this idea of definitions here. Or in Python, they're called functions. So I'm just going to call a main function. And that, of course, is you can think of as our main method that we have in Java. So this is just the name of it is main. And for Python, it doesn't really care because you'll see how it gets invoked later on. But here I'm just defining it. So in here, let's go ahead and just put for now our Hello World program. All right, and you notice that when I hit enter off of the colon from main, it automatically indented over because indentation tells me that this print statement belongs as part of this. And if I hit enter again, you'll see that it's still indented because it's expecting, well, maybe I want to do more stuff. So it's going to stay that way until I press the backspace key to have it leave. Now, I always like giving a little space there just because it looks a little nicer. So I'll hit one more, then I backspace over. So now I'm outside of that main method. And so to actually call it, I just do main, and that's it, with two set of parentheses because there's nothing being passed in for the arguments here, or the parameters for this function. And one thing you may have noticed already is I keep using the term function. In Java, we use the term method. They're the same thing. So method, function, some languages use the term procedure. They all mean the same thing here. All right, and so let's just test out, make sure I didn't make any mistakes. Hit OK, boom, hello world. All right, so now we've got our structure started. So when we start working with our Python programs, this is what we're going to want to do. We're going to have a def main, and then we put our programs inside of that. And then, of course, here's our main right here to call that. So when Python sees this, hey, I need to call that main function. Boom. All right, let's get into doing a little bit of variable work, for example. So I'm just going to go ahead in here and make a variable. Now, if you remember in Java, we had to declare the type of variable. So like, for example, I would have to say like int x equals 3. So int x equals 3, semicolon. But if you notice, if we look at that print statement, hello world, there's no semicolon. So again, no semicolon here. Like, okay, well, here I have int x equals 3. However, if I attempt to run this program, you can see that we get an invalid syntax. And that's because with Python, the way it structures up variables, it doesn't care about the type. It's going to pretty much assume the type based upon the value that's been put into it. So I don't need to say int x equals 3. I just say x equals 3. That's it. All right, so if I run this, you can see we still have hello world because I haven't output x at all. So now that's my variable. So I have x equals 3. Let's say I want to do another variable. Let's just say y equals 2.5 or 2.65. I'll just leave that in there. And so now I have a integer value and I have a float value because Python primarily works with ints and floats. So it doesn't necessarily get into more of the things we're used to. Java, it's like int and double. Python likes floats a little more. So if you remember, it has to do whether the bits are signed or unsigned. For our purposes, it's not really going to make too much of a difference, but it's still a little thing to kind of keep in the back of your mind about how numbers get handled with inside of Python versus how we're used to seeing them handled inside of things like Java. All right, but let's actually dive into this, and I'm just going to make one more. I'm going to do like z equals 0. Just a simple one. All right, now, of course, I can have another variable. Let's just say sum, and say that equals x plus y. And let's go ahead and print sum. Now, you'll notice that sum got highlighted, and that's because this is probably going to be a reserved keyword with inside of Python. So if I try to run this right now, we get 5.65. So it worked, all right? But generally speaking, if you see something highlighted like that, it may not necessarily be a good idea because it might be a reserved keyword for some kind of process or operation with inside of Python. For example, you see like print got syntax highlighted because print is a command with inside Python. So I just changed it to sum1. So that way I know, hey, I'm not overwriting something that Python wants to use. This way it's okie dokie. All right. So now there it is, 5.65, hello world. Awesome. All right. Now, of course, I could just do directly in here x plus y plus z, for example, just like we would do inside of Java. Nothing really changed there, just a little bit changing with the how we construct that print statement. But other than that, variables largely function the same. Now, let's say I want to do a little bit of concatenation. So here I have hello world, right? And I want to concatenate in that with, let's say, sum1. All right. So I just concatenate that. That's pretty much how we do it in Java. And you notice, we got a trace back here. All right. Now you notice that there is an error here. It says type error can only concatenate string, not float to string. All right. And remember, I said this is a float type. So what we have to do is that we have to convert that over. We have to typecast that from the float to a string, because in Python, strings are primitive types. So I have to add str in front of that and encapsulate that in parentheses. Now, it is a little bit different than how we're used to doing in Java. In Java, we would put, like, str, for example, would be the thing in parentheses. In Python, it's the other way around. It's the parentheses go around what we want to typecast rather than what it's being typecast to. So it's a little different than what we're used to, but it's largely going to kind of work the same. So once I've done that, let's go ahead and F5. Hey, look, there's my 565. Beautiful. All right, again, this is stuff that we're pretty familiar with working with, but nothing really too drastic. All right, one more thing that we do definitely need to look at, though, is the ability to capture some input. So if I want to just get input and not store anything, I can just use the input command. And that would then, of course, you could just say input, and that would just get input. Of course, just like you know, it's like if you don't store it in something, it just gets tossed out of memory. So we need to put that into something. So let's just say I want to say, let's make a variable called user input and have that equal input. Now, the one thing about this, though, is if I just put input there, the screen's going to be just sitting there, and we're not going to know what it wants to say. We could put a message here that says, like, print, please enter your name. All right, that's one way of doing it. However, there's a little trick we can do in Python to actually make this code just a wee bit cleaner. So I'm going to actually put that inside of this input statement. So let's hit F5. Please enter your name. It says none. All right, and that's because of where I put this input. Now, if I move this, just got a little rusty here with some of my Python here, so I might just have to move that around a little bit. There we go. Please enter your name. All right, so now it's currently waiting, so let's just try entering a name. Name. And our name is name. Beautiful. So if I want to do an input, I could do a print statement and then just do input, or I can do a input inside of the print statement itself, which actually helps condense down my code a little bit. So this is a nice little trick that Python has that can really make our life pretty nice. Now, of course, if I wanted to get a user number, print input, and say, please enter a number, the issue that we're going to have right now is that even though I have it asking for a number, by default, it's probably going to be stored as a string. So what I need to do is attempt to put this value that gets inputted as a integer, for example. So if I say parentheses int, parentheses, so let's try that. All right, please enter your name, please enter a number, 5. All right, so we got 5. Now, how can we know if that is actually a number? Well, it's simple. We could just do a mathematical operation. So let's just say print user number plus, and let's just do sum1. And that's a quick way to know whether or not our number is being used correctly. So name 5. Okay, we got a type error here. Okay, so part of the reason is that if you remember, we made this an int. Someone is a float. So let's just change this here to a float here and just see if that resolves our error. So name 5. All right, still got an error. So it says blah 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 blah. Line 10, line 11, 10, 12, unsupported operand types for none, type, and float. All right, so it didn't like that this right here was a input. All right, so just make sure someone. So it must not know what user number is. So I'm just going to actually just take this print command out of here. And forgot to take that parenthesis off there. 5, hit OK. Name, and then number, let's say 5. There we go. So it was the print command that was throwing it off. All right, so you don't have to print this out. That's simply just an echo at this point. So if I didn't want that to be there, I could just take that off, boom, boom. Now it's just input, please enter your name. It stores it as a string. Here, I have a float cast, which makes this a float. I could easily make it an int as well. Change it back to int. And of course, if we run our program, I have a right console window here, name 5, 10.65. So there we go. That's our quick and dirty way to get into Python. You got to see it live, see me make a couple crazy mistakes, but nothing really too unknown, but some things that you might see yourself run into as you start diving into Python here. And when we come back next time, we're actually going to do some different things in regards to strings. We start getting to some string methods because if you remember in Java, we used to do a couple different things with string methods. So we're going to see how we can do those same things with Python before we can branch out and start really exploring a lot of the other things that we're used to, like conditionals and loops and stuff like that. So until then, I will see you next time.